Hello, so here I have two math problems I'm going to do. It's about decaying. At the beginning, the question says, at the beginning of the experiment, scientist has 344 grams of radioactive goo. After 75 minutes, her sample has decayed to 43 grams. At what rate is the radioactive goo decaying? Answer in a percentage. So we will have here the formula. So Y is the new value, A is the initial value, R is the rate of growth or decay, and T is the amount of time it takes. So we are given the Y, which is the new value right here. And we are given the initial value, which is 344 grams, and the time, which is 75 minutes. So now we're just going to have to input it in a formula, which gives me 43 equals 344, e raised to the r t, which is 1025. You divide the 43 by 344, and then we have this. Now we isolate the natural log. We use the natural log to isolate the r times 75. So now that we do that, we get natural log of 43 over 34 equals r times 75. We divide by 75, and now we have the natural log of 43 divided by 344 divided by 75, and that gives us the r value. We put that in the calculator. We get the r value of negative 0.0277. To get the percentage of the decay, we need to subtract the rate from 1, which is 100%. So 1 minus 0.0277 equals 0.9733. So now we convert it to percent by multiplying by 100, and we get 97.33%. For question 2, we do the same thing. And so how much radioactive goo would be left after 90 minutes? So we answer in terms of grams. So from the previous question, we have already learned that the rate at which it decays. So now we can plug in the new number for T and solve this question. So all we have to do is plug it all in the calculator. 34 times e raised to the negative 0.0277 times the 90, and it will give us 28.4356. And so according to the instructions here in the video, we have given these two examples, and we use this, well, actually people mostly use this when they're like scientists or whatever, and as regular human beings, we are probably never going to use this as much. But I think some of the common mistakes that we sometimes will see with natural logs is that we forget to, do the natural log of anything. So we get to this point and then we're kind of just stuck. At least for me, that's what happens.